Alright, we're going to do another example, and you're going to find this is a rational function, so we are going to find some major differences, but we're still going to use those same steps that I outlined for that other problem that we just did. So the first step that I'm going to go ahead and do is derive this, because we're going to be trying to locate our critical values. Okay. And I am just going to take it, I'm going to take this and rewrite it before I derive, x plus x to the negative 1. And again, I do that just because I'm lazy and I'm trying to find the quickest way to derive. So I'm going to go ahead and find the derivative of x, which will just be 1, and then plus, and then the derivative of this thing would be negative 1 x to the negative 2. Alright, I will rewrite that. Okay. Alright, and then just to get these all lumped together, I'm going to get these combined, so I'll need a common denominator. I'm going to multiply this term, top and bottom, by x squared over x squared. So I'm not changing the value of it at all. I'm just changing looks, pretty much. So this is what I have. There is my derivative. So like before, I need to now establish the critical values, and unlike the other example where it turned out the derivative was a polynomial, this is a rational function, and so I'm not only going to be looking for when the top is equal to 0. When the top is equal to 0, then that rational function is equal to 0. So we found a critical point. But I also have to look at the bottom. When does the bottom equal 0? Because the critical values, they occur when f prime of x is equal to 0 or undefined. So we got to set both top and bottom. So I'm going to go ahead and set the top, x squared minus 1 equal to 0, and solve. I'd add 1 to both sides, square root it. X is going to be plus minus 1. There is one of my critical values. Alright, or actually 2 of my critical values. And then I'm also going to look at when x squared is equal to 0, set that bottom, and so when x is equal to 0. I have 3 critical points here. I'm going to go ahead and write that on my number line, or sign line. I'm going to mark in my critical values. I have one at 0, I have one at negative 1, and then I have one at 1. So I'm just going to, right off the bat, I'm going to give us, or look at the intervals negative infinity to negative 1. Okay, that would be this interval right here. I'm also going to have to consider from 1 to 0. Be this interval right here. I'm also going to consider 0 to 1. Oh, sorry, this should have been negative. And then from 1 to infinity. All of these I'm going to have to write as either increasing, decreasing, increasing, or decreasing. Alright, so simply all I need to do is test the derivative. I'm going to go ahead and test negative 2 here, so f prime of negative 2. If you go into your equation, this one right here, of course, this is the equation of the derivative. So I'm going to get negative 2 squared minus 1 all over negative 2 squared. So we are going to get a positive. And that means this is increasing. Okay. I'm also going to test the point. This one's a little tricky. We would have to test negative 0.5. So on the top here, I'd get negative 0.5 squared minus 1 all over negative 0.5 squared. On the top, we are going to get negative, and on the bottom, we are going to get a positive. So what you'll have to say is this overall is a negative. Okay, so this is decreasing. And I'm going to keep on testing these. So I'm going to have to move on to the next page here soon. But f prime of 0.5, let me plug in that. This 2 is going to be negative. Because the top is negative, the bottom is positive. I have decreasing. So that translates. Once again, what we're doing is we're finding the derivatives in that interval. And once we test that point, we can determine by if it's positive or if it's negative. That translates to our original function as either increasing or decreasing. 2 squared. That's going to be positive. So here we have increasing. What I've done is I've transferred the key information from the previous slide onto this one, just because I ran out of room. What we still have to find out is the relative extrema. So where are the relative minimums and where are the relative maximums? So I didn't really go into this one as much because it is on page 330 of your textbook, going back through all of our work. Number 4, that's step 4, and locating these relative extrema. They do have this process on page 330 for you. But basically, think about it intuitively if you want. If we know that this is going to be some sort of critical value, we're saying that, alright, as we're getting closer and closer to this from the left-hand side, it was increasing. Alright, that's what this indicates. And then it's decreasing. So that has to be, think about if you're increasing, and then all of a sudden you're decreasing, it's like you were walking up a hill and now you're going down a hill. So we do know that there's possibly a relative max at, and then -1, comma. Alright, but now we have to ask ourselves, what is that y value? So this is where you would actually have to take that -1 and plug it into our function. I'm going to do that work to get that y value. I'll do that work off to the side. Equals, we get -1 plus 1 over -1. So in other words, at -2. So there's going to be a relative maximum. This point right here, this one is interesting. We have to ask ourselves, alright, it was a negative and then it continued to go negative. So there's a couple things that you could do. I would just say, alright, you can't really use that theorem on page 330 about this. So think about, alright, let's plug in the point f of 0, see what's happening there, and then possibly go from there. So if you plugged in 0, you're going to get 0 plus 1 over 0. So this is actually not what I would say is a critical point. It's a little bit bizarre, but it's not a critical point. So you really had to kind of think about what was going on there. And when I plugged in that 0, it's not actually a point. Okay, so what you can say is that's no critical point, therefore no relative extrema. Alright, and the very last one, we're going to do the same thing here. It is one of those instances where it was decreasing and now it's increasing. And so think about it like this. You are going down and then you're going up. It has to be a tip of a valley or the lowest part of the valley. So it's a relative minimum at, and then I do know it's at 1, comma, and what is that value? We're going to actually have to figure that out. Get the y value by plugging it in, plugging in the x value, 1 plus 1 over 1. So, in other words, 2. This is all of our key information, and I'm going to kind of have you flip back and forth, but I'm going to just kind of pick these out. Relative maximum at -1, comma, -2. -1, comma, -2. That is a relative maximum. At 1, 2, that was a relative minimum. And what you would have seen is Before that, it was increasing, and then it started decreasing. It was decreasing, and then it started increasing. And we can see what was exactly happening at that x equals 0 that we did find as a critical point, but then when we actually tested it in, it didn't produce any kind of relative extrema. So there was an asymptote there. I'm going to go ahead and put up the homework assignment. Just